Raghaji, shall we start or we need to
Y-
wait?
Yeah, we can start. Can start. So I make you the host.
Okay. So yes, right. Okay. Good evening. Right. So good evening,
Sir,
all.
good
Yeah.
evening, sir.
Yeah.
Sir, please discuss in slowly, sir.
Okay. Fine. Yeah. Right. Welcome you all to this course on the ETAP. So first, let me introduce myself. Myself Venkatesh, and I am an experienced power system studies consultant. I have comprehensive background in electrical engineering, specialization in the power system analysis and design, and I have a deep understanding of the various aspects of the power system generation, transmission, and distribution systems. Coming to my educational background, I hold a degree in electrical engineering in 2008, and my academic journey has equipped me with a solid foundation in the principles of the electrical systems. And I have continued to expand my knowledge through ongoing professional development, staying current with the latest advancements in the power industry. Coming to my professional experience, I have a significant amount of experience working in the field of the power systems. Near about 16 years I have spent in both the industry and the consulting roles. And my work has spanned across various aspects of the power system, starting from the generation, distribution, grid management, renewable energy integrations, and so on. And coming to my proficiency in the power system analysis software, I am proficient in a variety of industry standard power system analysis tools like ETAP, Dixel Power Factory, PSSC, PSCAD, and EMTP. In addition to that power system analysis capabilities, I am well versed in solar designing tools also, including PVSys, PVSOL, and helioscope, etc. And I had the privilege of working with the diversified clients, including utility companies, industrial facilities, power generation, and renewable energy energy developers also. Right. So this is a brief introduction of myself. And coming back to our course, we are going to continue the course for near about some 10 to 12 weeks. And the approximate time will be of some 40 to 50 hours. Before that, I just want to know how many of these in the group are already aware of the ETAP. Means, have you people have previously worked or having any hands-on experience on the ETAP? Can you just reply quickly on the chat?
No, sir. No, sir.
Okay. None of the the group is having the experience. Okay. Rakesh Kumar, no. Prakash is also no.
Yeah, most of the participant is the new to the system studies ETAP software. Venkatesh.
Okay. Okay. Fine.
And here we will cover the ETAP topic only, not the PSCAD and EMTP. So I don't think that it will go around 10 to 12 weeks. That easily we can cover into 2 weeks max to max. Only the ETAP.
Yes.
Topic that we are, and if this once this training program finish, and if the participant is interested, we can have another training program. In that we will go with the PSCAD. So first, this is dedicated for the ETAP only.
Okay. Fine. Yeah.
Yeah. Okay.
Right. Yeah. I think almost everyone is having no experience in the ETAP. No issue. Fine. Right. So first, let me share my screen and right. Okay. So is my screen visible?
Yes, sir.
Yes. Right. Okay. Right. So coming to the ETAP, ETAP basically stands for the Electrical Transient Analyzer Program. So this is a very powerful analytical engineering software, and this basically helps to simulate and analyze the steady state and the dynamic power system. Nowadays, almost every utility is using the ETAP. It may be either generation, transmission, distribution, industries, and low voltage utilities also. Everyone is using the ETAP. And now ETAP is becoming the prior requirement for almost all the industries. Why ETAP is becoming so popular? Let me note it down also. We will, during the course, we will try to note down the important points in the Excel. And I will share this Excel after the class. Right. So ETAP, the expansion form of the ETAP is clear, that is Electrical Transient Analyzer Program. So why the ETAP is becoming popular? So basically there are three reasons. The first and foremost thing is its user friendliness. That means anyone can learn the ETAP and anyone can work in the ETAP very easily just with a matter of practice. Next one is ETAP is having a vast capabilities, or you can say it as a wide range of capabilities. Means this should be capable of doing various studies such as load flow, short circuit analysis, arc flash, protection coordination studies, cable pulling, earthing, cable ampacity studies, and much more. And the third reason is the integrity portion. Means integrity means it has the functionalities, and it can be integrated with the other softwares, like it can be integrated with the PSSC software. It can be or the PSSC software, like the raw files of the PSSC format can be imported into the ETAP files. So basically, similarly, it can be integrated with the MATLAB. So there are many other simulation softwares with which the ETAP can be integrated. So these are the three basic reasons why ETAP is becoming so popular. Okay, so because of these three reasons, ETAP is getting more and more acceptance across the industry. Right. Next, coming to the introduction about the course. So in this course, basically, we are going to cover various topics, starting from the requirement of the power system analysis. What are the softwares that are used for doing the power system analysis, different type of power system studies, and then we will see some introduction into the ETAP software. We will learn about the ETAP tools, familiarization of the ETAP, okay, and different features that are available with the ETAP software, and then we will go into some topics pertaining to the steady state analysis. So basically, I have designed the course keeping in mind that not only from the software perspective, but personally, I want to explain the concepts which will help not only for the ETAP, but also for any other power system simulation software. So in this course, especially, we will talk on the steady state analysis, but I will try to briefly touch upon the transient studies as well, just to make all of you at least a familiarization of the studies. So the purpose of this training is to learn how to apply the engineering knowledge in the power system modeling, design, and the analysis using the ETAP software, right? And talking about this is the agenda of the program. So talking about the agenda of this program, we will start with the introduction of the power system studies, and then we will try to understand why we need to use power system analysis softwares like ETAP. In this, we will discuss some interesting aspects of the industrial power system design. Then we will get started with the ETAP and the ETAP software overview, in which we are going to learn about how to create new projects and try to understand what are the different tools that are available in ETAP. And we will also try to understand different modules that are available in the ETAP. So basically, this is nothing but the familiarization of the ETAP software. Next, we will continue with the creation of the single line diagrams, which is the first and foremost requirement for doing any analysis. Rating of the components means how to give the rating of the components of the power system equipments, and details about the various electrical equipment parameters that are needed to carry out further analysis. And we will also learn about the creation of different templates in ETAP, and how can we customize the libraries, all those details, like adding or deleting any equipment from the library. So all those details I will try to cover in the ETAP. During the course, whenever possible, I will try to explain some hand calculations also, so that it will be more clear to you from the conceptual point of view. Yeah, see, if you simply create an SLD, enter the different parameters, and then give the simulation to ETAP to run the load flow analysis, ETAP will run and it will give the results. That is quite simple, and anyone can do that. But we must understand the concept behind those calculations, how ETAP is performing the calculations, what is the theoretical background behind those calculations, how ETAP is doing. Learning those things is important. So if that is clear to you, then performing the simulations in ETAP is not a big deal. So I will try to explain those concepts also during the course. Next, coming to the details of the different modules that we are going to cover in the ETAP. So we start with the modeling of the grid elements, then load flow analysis, in which we will cover the load flow fundamentals, perform various load flow analysis, and we will also cover the transformer sizing, multi-generator load shading, and how to analyze the reports, and multi-generator load sharing. So multiple things that we can see in this load flow analysis. So basically, load flow is called the mother of all the studies. This is the main study required to carry out in order to proceed for further studies. Means the results of the load flow will be used as an input to the other studies. Then we will perform short circuit analysis. So in this, again, we will understand the short circuit analysis fundamentals again and different case studies of short circuit analysis. Just 1 second. I'm getting what you call. 1 second. Okay, bye. Yeah. So basically, we are, yeah. Right. Next, coming to the short circuit analysis, in which again we will try to understand the short circuit analysis fundamentals and the different case studies we will see for the short circuit analysis. Then we will move on to the protection device coordination, which is an elementary requirement for any type of protection system. I will also discuss about the protection system fundamentals and the study of the coordination principles and to how to evaluate the star protection device coordination with some typical examples we will see. And then I will cover some motor acceleration studies like motor starting studies like steady state analysis and dynamic starting analysis. So all those things we will also try to cover. And next we will cover the harmonic analysis fundamentals and the study of the harmonic analysis using the ETAP and the designing of the filter circuits and so on using the ETAP software. Right. So those specifically I have not mentioned here, but I will try to cover some more important concepts which are necessary to understand for doing the power system analysis. Also, myself along with Mr. Raghav, we will ensure that this course will not only help you to know the ETAP software operation, but you will also get sufficient knowledge on the subject in order to execute power system analysis projects on your own. I hope you will enjoy learning the course, and you people are always welcome to provide your feedback for the further improvement. Any doubts at any point of time, you people can stop me and we will definitely, we are ready to clarify them. Okay. I hope this is clear, right?
Okay, sir.
Yeah.
Yeah, yes, sir.
Right. So today, in the first session, we are going to discuss on introduction about the power system analysis. So basically, we are trying to understand what are the studies which are available and why do we need to perform the studies and when do we need to perform the studies. That's all we are trying to understand as a part of this session. So when we say power system analysis, we are going to talk about how this power system analysis can be majorly classified and the sub-classification in the software. So let me take the help of the Excel here. Right. So here, let's start with the power system analysis software. Power system analysis. Right. So power system analysis is majorly classified into two types. One is steady state analysis steady state analysis, and the second one is the dynamic analysis. Or you can say it as a transient analysis also. It's better to rename it as a transient analysis instead of the dynamic analysis. Okay. So basically at the higher level, power system studies or the power system analysis can be classified into steady state analysis and transient analysis. Now, what is the steady state? What is the steady state? Any idea? What is the steady state? Any idea like what is a steady state? Okay, fine. So when what is the steady state? Means when you are studying the system, not really with respect to time, but with respect to state, which is stable, then it is called as a steady state analysis, right? Means I am assessing the or analyzing the performance of the system. I am analyzing the performance of the power system with respect to only one instant. Then this is the steady state. That means we are analyzing the system or we are studying the behavior of the system at only one particular state or one particular instant. So that's why this is called as the steady state. And coming to the transient analysis, when I'm studying the behavior of the system with respect to time, then it is a transient analysis. So here, if you write here, this is analyzing the performance or the behavior of the system with respect to time. Here, in the steady state analysis, we are analyzing the behavior of the system with respect to only one particular instant, whereas here we are analyzing the behavior of the system with respect to time. Okay, then that is called a transient analysis. Or here I am seeing the system, I am seeing how the system behaves with respect to some disturbance or with respect to some events, with respect to time. So then that is a transient analysis. So is it clear up to this transient analysis?
Yes, sir.
Right. Now, the transient analysis is further classified into two things. One is electromechanical transients and the we can write it here, electromechanical transients and electromagnetic transients. Right? So are you clear about what is the steady state analysis and transient analysis? So steady state analysis is nothing but analyzing the performance of a power system or analyzing the behavior of the power system with respect to only one particular instant. And this is not really going to study any parameters with respect to time. When we say example 100% voltage, it means 100% voltage. It is not really going to say how this voltage is changing from 100 to 100.1 or 100.2 or 99 in the next moment or the next second, next minute or next hour, something like that, right? So it is not really going to check or it is not really going to analyze any of the system with respect to time. But here, when you are talking about the transient analysis, let's say if the breaker open or if fault happens, how much time the breaker is taking to open, etc. And what will be the current or the voltage profile at that moment. If you want to study that with respect to time, then it is the transient analysis. So if you are analyzing or assessing the any system performance on a single moment at one instant, then it is a steady state. With respect to time, if you are studying, then it is a transient analysis. After talking about this transient analysis, we have to talk about two important transients, whether it is an electromechanical transient or electromagnetic transient. So let's first talk about the electromechanical transient. What is electromechanical transients? So basically the electromechanical transients involve the study of interactions between the electrical and mechanical components. That means specifically, let me do it here. Yes. Right. Right, fine. So electromechanical transients involves the study of interaction between the electrical and mechanical components. That means specifically examining the relationship between the electrical components, like what are the electrical components, like transmission lines, cables, loads, transformers, and the mechanical systems like turbines, steam turbines, gas turbines, hydro turbines. So when we analyze the interplay between the electrical and the mechanical systems, particularly the turbines, we refer it to as an electromechanical transients. And if we are discussing the interaction between the electrical system with the mechanical system, which is predominantly turbine, right? Then we call it as an electromechanical transient. Say, for example, let's say if there is a three-phase fault on the overhead line, how the generator rotor oscillate with respect to other generator, that comes under the electromechanical transient. So what is the electromechanical transient? It is nothing but studying the transient behavior between the electrical system and the mechanical system. This is more specifically applicable where you want to study the system within a time step of few milliseconds. In the electromechanical transients, we will analyze the system for the few milliseconds. For example, if there is a three-phase bolted fault in a 400 kV system, and the fault maybe persists for, let's say, 100 milliseconds, and you are studying or you are trying to study the relative angle of various generators for, let's say, 1 second or 2 seconds or 10 seconds or 20 seconds. So that comes under the electromechanical transients. So electromechanical transients, the example what I have given below means what I have given here is the rotor angular stability. So what are the, whatever the I am talking about, like how the generator rotor oscillates with respect to the other generator. So that will come under the rotor angular stability. Right. Next, coming to the electromagnetic transients. So these are nothing but the electromagnetic transients. Okay, I will discuss it later. Right. So electromechanical transients, we have discussed till the rotor angular stability. It can be further classified into many things. Like what I have talked about is one example, that is the rotor angular stability. Coming apart from this, we have the voltage stability, LVRT study, especially for the solar plants and the means the RE plants, I can say solar, wind, or whatever it may be, the BESS, and HVRT studies, frequency ride through studies, of the fall through ride studies. So whatever we are doing are considering are the electromechanical transient. Okay. Next, coming to the electromagnetic transient, this is nothing but the study of the interaction between the electrical system and the magnetic system. Right. And this is basically talking about the interaction between the electrical system and the magnetic system. So let me note it down. Study of interaction between the electrical and the magnetic system. Okay, and this is basically talking about the interaction between the electrical and the magnetic system, but not the mechanical system. And this interaction between the electrical and magnetic system happens probably in microseconds. Right? So if you take the example of a lightning, or a switching event. So the event happens, and if you take the case of a lightning, the event itself happens probably in 1.2 by 50 or 8 by 20 microseconds, right? to take the case of the lightning event itself happens in either 1.2 by 50 or 8 by 20 microseconds. So the total duration of the time itself is quite less. So what is the time step which you need to use? Like very, very small. Whereas in the electromechanical transient, the event happens in few seconds. So if you are putting the time step as a few milliseconds, it's good to go in the electromechanical transient studies. When I'm studying like sudden the load is disconnected, what is the rise in the frequency? If you want to check that, I need not to run the simulation with the microseconds or nanosecond time step. If I'm running those simulation with a few milliseconds, that's good enough. But if I'm doing the lightning study, when there is a lightning strikes on the overhead line, ground wire, what is the rise in the voltage on the tower? If I want to study this, I cannot probably use the time step of maybe 0.01 millisecond or something like that, because the lightning waveform itself is like 1.2 by 50 microseconds or 8/20 microseconds. So electromagnetic transient is used to assess the performance or the interaction between the electrical system and the magnetic system, and the time step for this is in microseconds, whereas in the electromechanical transient, the time step is in milliseconds. Okay, I hope is it clear?
Yes, sir.
Yes.
So, yeah. So power system analysis is basically classified as steady state analysis and the transient, right? So transient is further classified into electromechanical and magnetic. So this is just like a major classification of the power system analysis, and how this steady state analysis and transient analysis is sub-classified is what we are going to see. Okay. Now let's look at and try to understand what are the studies that come under the steady state analysis. Any idea? What are the studies that come under the steady state analysis?
Power flow.
Any idea?
Power flow, sir. Power
What
flow
is-
analysis. P and Q, sir.
Sorry? You can put in the chat. You can type in the chat. Yeah, load flow. Yes. You can type in chat. Right. Okay. Short circuit. Right. Perfect. Okay. So as I said earlier, the steady state analysis is nothing but the analyzing the behavior of the power system at any instant, at any one instant, and assume that the system is steady, but we are not assessing the system with respect to time in a steady state. Next, what are the studies that comes under the steady state? Like load flow analysis. That's what we are going to cover at the beginning, and even short circuit analysis. Okay, that's also a steady state. And if you talk about maybe the motor starting, especially the static motor starting study, that's also a steady state analysis. If you talk about maybe the relay coordination, and if you talk about the arc flash and harmonic analysis. So all these studies, what we are doing comes under the category of the steady state analysis. So whatever may be the studies which you are seeing here as a part of the steady state analysis. Now let me ask one question. Just try to think and give me the answer. Short circuit analysis, whether it is a steady state or a transient. Any idea? Whether it's a steady state or transient?
Transient.
Transient analysis, sir.
Okay. Any other answers? The short circuit study
The study.
is a steady state as well as it is a transient.
For steady state, sir.
So it is both steady state and transient. So when you talk about a short circuit study, You can perform short circuit studies in a steady state, or predominantly the short circuit study, what we are performing using the ETAP software is a steady state. It doesn't mean that we cannot perform a short circuit study in the transient. We can perform the short circuit studies in the transient also. Yes, we can perform transient short circuit also. Like there is something called a steady state short circuit and a transient short circuit. Okay, like if you are using the standard that is IEC 60909, that is a steady state. Whereas if you are using a standard IEC 61363, then it is a transient short circuit. So when you are using this IEC 60909, that's a steady state short circuit. And if you are using IEC 61363, that is a transient short circuit. Why? Because when you go through this IEC 60909 standard, it is applicable for a short circuit calculation in a low voltage or medium voltage 3-phase AC systems and high voltage AC and 3-phase AC systems operating at 50 Hz or 60 Hz. So this standard predominantly talks about performing a short circuit studies under steady state condition. There is another standard that is IEC 61363, like this is a transient short circuit. And if you search in the Google also, you can find the difference between this 60909 and 61363. So the major difference between these two is one is for the steady state short circuit and another is for transient short circuit. Now the question comes here, why I call short circuit study under 60909 as a steady state analysis but not the transient analysis? If you have performed short circuit studies in ETAP using 60909, by any chance, by any time, it is not possible to change the instant at which the fault has occurred in the waveform. Okay, like say for example, let me take MS Paint here. Right. If I take a typical sinusoidal waveform, something like this. Okay, so in a sinusoidal waveform, is there any place like the fault occurs at the maximum voltage, the minimum voltage, or probably means the fault happens at the negative maximum, or the fault happens at the positive maximum, etc. It is not possible to select when you are using or when you are performing the short circuit using 60909 standard. That means, so when you are doing the short circuit study in ETAP, you will not be able to change the instant at which the fault has occurred. What I mean? That means, if you take the sinusoidal wave here, whether the fault occurs at this instant, or whether the fault occurs in this instant, or whether the fault occurs in this instant or at this instant, you will not able to change that when you are performing a short circuit studies in using ETAP. Okay, like if you see, if a fault happens here, the fault current will be different. If a fault happens here, the fault current will be different. So whereas if the fault happens here, again the fault current will be different, right? So at a different instant of the waveform, the fault current will be different. But in ETAP, what we are doing, we are talking only about the fault current at only one particular instant. Okay, right. So here in the, yeah, please, any doubt? Any doubt?
For why it is referred in
Sorry, why?
steady state?
I am not able to get your question.
Sir, why it is referred in steady state? Basically,
Okay, yeah,
this
that I will
waveform,
tell.
it is
See, in the ETAP, you can able to perform means the short circuit using 60909 also and 61363 also. So why it is different? I will explain. When you are performing the short circuit with the 60909 standard, you are performing at only one particular instant, right? As I am talking about, right? See, in the short circuit, basically we are talking about, there is two components like IK double dash. Let me note it down here. So in the short circuit, we have IK double dash. This is nothing but the asymmetrical short circuit current, and IDC, not here, IDC, this is the DC component of the current, and the third one is the steady state current, which is IK. Okay, so when we are performing short circuit, what are the different current which we will find out is IK double dash, IK, IDC, and IK. Okay, what are the different currents that you have found out is these three currents. One is the subtransient current, IK double dash, the transient current, IK dash also we can give here, IK dash, and DC component of the short circuit, that is IDC, and the steady state current, that is IK. So these are all the different currents which you can study while performing the short circuit. Irrespective of the instant at which the fault has happened, the steady state current, this IK, the steady state current IK will remain same, and all other components will be different, including the IDC. DC component also will change with respect to the instant at which the fault has happened. So the DC fault current will change your asymmetrical current, which will change this IK double dash and IK. That means the entire wave shape of the fault current itself will be different. And after that, the system settles down. Let me share one small image. Wait. Asymmetrical. Current IDC graph. Right. Yeah. Right. Yeah. If you see this image here, if you see at the first instant, 1 or 2 cycles, you have the fault current is different. And here the fault current is different. Here the fault current is different. And once it gets settled down, so this is the steady state current. So the steady state current will remain same irrespective of the instant at which the fault is happening. Whereas the other components like the IK double dash and the IDC, IK dash, so these are varying with respect to time, and these are varying with respect to the instant at which the fault happens. So basically 60909 talks about the steady state current, which is a constant irrespective of the instant at which the fault happens. So that's why the short circuit study, whatever we perform using the ETAP with 60909, that is the steady state short circuit. Okay. Whereas if you perform the short circuit analysis for 61363, then that is the transient short circuit, because in this we are going to analyze the both IK double dash, IK dash, IDC, everything we are going to calculate in IEC 61363. Okay. Is this clear?
Yes, sir.
Right. Now,
Yes, sir.
next, one more point is the steady state value, whatever we are discussing here, that is a theoretical value, which means it will never happen in the system in practical. Because whenever there is a fault, your protection system isolates the fault in the transient region itself, not really in the steady state. If you allow the fault current to reach a steady state here, which is a value much before that your equipment would have been already damaged, right? Generally, not generally, by default itself, you might have designed your system to withstand a short circuit current, not for an infinite time. You might have designed the system to withstand a short circuit for a specific time. Like for example, transformers. The transformer withstand the through fault current for 2 seconds. Switchgear, 1 second. Cables, 2 seconds or 3 seconds or 1 second, something like that. Even if you protect the cable by a fuse, so it may be like fuse operating time or the lead through current. If it is a breaker, 0.12 or 0.15 seconds, something like that. Depends upon what is the sizing criteria that you have been selected. So for each and every equipment in the power system, they are capable of withstanding the fault current only for different time. It's not for an infinite time, right? If that is clear, just put the CC in the chat. Is it clear up to this?
Yes, sir.
Yes.
Yeah. So basically, our system is designed to withstand the short circuit for a definite time, but not for an infinite time. So steady state value is just like a theoretical value, which is of no use as far as the practicality is concerned. All right. Now, coming back to this asymmetrical current, if we about this asymmetrical current, this is the asymmetrical current, right? This is having the DC current as well as the peak value. All these things will change with respect to the instant at which the fault has occurred. Like if the fault happens here, the asymmetrical current, peak current will be different. Whereas if the fault happens here, again, all those currents will be different. But your steady state current, that IK, which settles after few cycles, this will be constant. Okay. Right. I hope this is clear.
Yes, sir. Yes, sir.
Yes, sir.
Right. So next, so this is about the short circuit. Means I'm not going much in depth into that. So if you go in depth in the first grade itself, probably you people will feel bored. Right. So next, coming to the transient analysis here. What is the transient analysis? So as I mentioned, the transient analysis is analyzing the performance of the system with respect to the time, and it has been classified into two categories: electromechanical or RMS transients and electromagnetic transient. So under the category of the RMS, there are further studies which come in like the rotor angular stability, voltage stability, LVRT, HVRT, etc. But coming to the electromagnetic transient like lightning, and here you have slow front over voltages, fast front over voltage, transient recovery over voltage studies, ferro resonance, and VFFO, very fast front over voltages. So these are all the studies which comes under the category of the EMT study, right? So let's probably make it clear at the beginning itself, like how these power system studies are classified. So power system analysis studies are classified mainly as steady state and the transient analysis. I mean, steady state analysis like load flow, short circuit, motor acceleration. Of course, the short circuit, as we discussed, it is both steady state as well as transient. Motor starting, relay coordination, arc flash, harmonics, all these studies comes under the category of the steady state analysis. And when it comes to the transients again further classified into electromechanical or RMS and EMT studies. And this RMS study is like an angular stability. And probably if you want to do the study for grid islanding, finding out the critical fault clearing time. So these will all come under the classification of the electromechanical transients. So these are the kind of studies which comes under the category of the RMS, and studies like slow front over voltage, which is logically the switching studies, fast front over voltages, that is logically called as the lightning studies, and very fast front over voltage, which is applicable only for the GIS substations, and transient recovery voltage and ferro resonance. So these are all the studies which comes under the category of the EMT. So as a part of our training, what we need to just essentially understand about this transient, but we are not really going to cover this. In this course, we are specifically focusing on the steady state studies only. Hope this is clear to all of you, right?
Yes, sir.
Yeah. So next, coming to the simulation softwares being used for this EMT, there are some special simulation tools which are available. And logically, as of now, only two tools. One is PSCAD and the other one is EMTP. So these are the tools which are available to perform the EMT studies. So only two competitors. We need to ask a question like, what is the outcome of the study? If you want to decide whether you need a surge arresters or not. Like basically when you are performing the insulation coordination studies for your substation or whatever it may be, if you need any surge arrest or not, if required, how many surge arresters required, where they must be placed, what are the characteristics of the surge arresters, like category 1, 2, 3, 4, or deciding the basic insulation level or the switching impulse levels for the lightning and all. So let's say if you are selecting a 400 kV system, you will be having a quite lot of things. Say for example, for a 400 kV equipment, the continuous current is of 3140 amperes. This has to be validated by load flow. Okay, you may be saying like 50 kiloampere for 1 second. This can be validated using the short circuit, that can be validated, right? In addition to that, you may be having something like 1425 kV, which is basically the BIL, means the basic insulation level. In order to validate this, you need to perform these studies. Whether you are necessarily looking for increasing the surge arresters or identifying the right characteristics, or you are increasing the BIL value of each and every equipment, that has to be studied as a part of the EMT study. So I'm just making you aware, like there is some study called the EMT study, which is available, and only PSCAD and EMTP-RV are the only tools which are available to these studies. And the purpose of performing the study is to find out whether the surge arrestor is needed or not, if required, how many surge arresters required, where it is to be added, what are the characteristics of the surge arrestor which you need to select, and for all the other equipments, it helps to find out what is the BIL, means the basic insulation level or the basic switching level. That's probably all about this EMT studies. Okay. So in this one, coming to the PS, this one, what to say? RMS means a steady state analysis as well as the electromechanical transit. You have plenty of softwares like ETAP, Dig Silent Power Factory, PSSC, Aspen. So there are so many multiple softwares are there. So you have SKM, Easy Power. So there are plenty of power system simulation softwares are available. Whereas for the EMT softwares, only two competitors, EMTP-RV and PSCAD. But if you take for this market, like we have infinite software. Though ETAP, we have PSSC, you have Dig Silent Power Factory. These are all the softwares which are quite popular in the market. Of course, you can have the other software like CME, Simon. So the list goes on go on. At least 50 commercially available power system simulation softwares are available, and about 20 free custom simulation softwares are available in the market. But the market is probably dictated by these three softwares, that is ETAP, PSSC, and Dig Silent Power Factory. Okay, ETAP dictates the market as far as the industrial distribution system is concerned, and it has geography like USA, Middle East, India, and probably, of course, all the Asian market and African market. Dig Silent Power Factory, this has an excellent, fantastic market in Europe and Australia, and PSSC has a strong market across the globe with respect to the utility, where we are performing a large-scale grid-connected systems. Like if you want to run the load flow analysis for the entire India, like almost all the utilities are using this software PSSC. So basically, the software PSSC comes from the Siemens, right? And probably the company GE came up with another software, that is PSLF. This is not really popular as PSSC, but there is a software which is available. And probably if you look at US market, PSLF has totally influenced that, because can everyone mute? Yes. Right. So this PLF is developed by the US market. So PSLF has totally influenced that, because obviously GE is a US based company and Siemens is a European based company. So these are all some simulation software which are generally available, right? Which will be available to perform almost all studies, right? Maybe except PSSC. If you take PSSC, with PSSC, we can only perform load flow, short circuit and stability, but with PSSC, we will not able to perform the motor starting study. It will not be able to perform the relay coordination, arc flash, and harmonic analysis. That's because PSSC is basically meant for the utility applications, and there will be able to perform only the load flow, short circuit, stability, RMS. It will not be able to perform other studies. But whereas if you take the other simulation softwares, except PSSC, they will be able to perform all these studies. Right. I hope this is clear. So this is a basic introduction about the power systems, means the types of the classification of the power system analysis. And in our course, we are completely focusing on the steady state analysis, not on the transient analysis. So I just want to give the have some awareness of what are the classifications of the power system analysis and what are the different softwares that we will be used for doing this analysis. So for that, I just want to give some introduction. So any doubts till now? Any doubts? Any doubts till now? Oh, wait. I just want to. Yeah. Sorry. Yeah. Any doubts?
No, sir, it's clear.
Yeah. So but today we will end the session because we want first day itself we want to go much in depth. So tomorrow we will start with the familiarization of the ETAP software. So tomorrow we will try to familiarization of the ETAP software and how to, and we will try to create some single line diagram using the ETAP, so that we will try to finish it off. Okay. So today first day I'm not taking much time. So if you people have any doubts, you people can ask me.
Just 1 second. When so tomorrow, what timing? You will be
Same time.
9 p.m.
Yeah.
Okay. Any possibility before that? Because tomorrow is Sunday, so most of the participant would be.
What's the preferable time?
I think we start, like, could we have 3 hours sessions, like 8 to 11 or 8:30 to 11:30, like that?
Yes, sir, we are comfortable with that.
So 3 hours everyone is comfortable? 3
Yes,
hours.
sir.
Okay.
But 15-minute break, sir.
Yeah, with some small break, like 10-15 minute break. Yeah, 9 to 12. No, 9 to 12 is late, my sir. So 8 to 11, 11:30, like that we can go.
Yeah.
Yeah. With one gap in between the.
Okay. Done. Because of today first day, so I have not make the people much bored about the theoretical concept. So we will directly tomorrow we will start on the ETAP. Okay.
So tomorrow from 8 we will start, right? 8 to 10.
Yes.
8 to
Can
10.
you make it
10:30,
8:30, please? Can you make it 8:30? Here it is working day tomorrow.
8:30 to 11:30 in that case, right?
Yeah, the other side, no problem. Starting, if you can make it 8:30.
8:30
Okay.
will be good. 8:30 can make 8:30.
Okay, Venkatesh, 8:30?
Okay, fine.
8:30 to 11:30, max 12 we can go.
Yes. Okay.
Okay.
Yeah.
Yeah.
Okay. Right. So for today, I
One
will
more thing.
Yeah.
One more thing. You mentioned these softwares. Which are the softwares which compatible for Mac also? Is there any software?
Oh, unfortunately, all the softwares work for the Windows.
ETAP has the Mac provision.
Okay.
ETAP has a latest version with the Mac compatibility. That's what it is. But you have to select at the time only.
Yes.
Okay, thank you.
Sir,
Yeah, right. Okay. So, right, we will end the session for today. So tomorrow we will start with our ETAP session. Like we start with the directly on the ETAP software. Okay. Right. Okay. Thank you. If you
When it is just a small request, if it is okay, then fine. Otherwise, no problem. Could we open the software ETAP and just cover that, just introduction part of the ETAP, like how to open the software, how to create the project, and how to select the standard. Just a small brief intro about the ETAP software, so that tomorrow we can start the load flow analysis.
No, Raghuvji, tomorrow we will give the familiarization of the ETAP. Don't be hurried, please. That's my
Oh,
sincere one.
no issue at all.
Yeah,
No
yeah.
problem.
But just tomorrow we'll go with the ETAP familiarization, because if we directly start the load flow analysis, it will be difficult to understand. So first,
Yeah, you go as
because
per you
almost
go as
all the
per your.
participants have replied that they don't have awareness of the ETAP. So if I directly go with the studies, probably it will be difficult them to understand also.
No problem. You go as per your plan. You go as per
Yeah.
your schedules.
Yeah.
I'm happy just to deliver the session in detail.
Yes.
Sir,
Yes.
there are no problem in time, sir. Please explain in depth, please.
Hello?
Yes, sir.
Yeah, please.
There is no problem of time, sir. You please explain deeply, sir.
Okay, fine. No, today I'm just ending here. So tomorrow onwards I will take a 2.5 hour session. So I don't have any problem in taking that, but my point is, as almost people are not aware of this, so probably it will be difficult to understand. So we will go a little bit slow in the initial classes, then like from 3 to 4 classes, we will go a little bit fast. Okay.
Yeah, it will be better because once it is all catched up, then we can go on.
Exactly.
Yes.
Because at least some familiarization is required.
Yes.
From the first day
More
itself, if I
technical
move
terms
on
and
fast, from the first day itself, if I move fast, so probably it will be difficult to understand.
Yeah, great. Yeah, perfect.
Yeah.
Yeah,
Okay.
all right, Venkatesh. All right.
Okay.
Thank you all. Thank you.
Thank you, sir. Thank you,
Yeah,
sir.
so Venkatesh will available for the ETAP, and if any query we can discuss, as well as I'm also available. So if anyone want to discuss with me any problem or with Venkatesh, he can approach. Okay, thank you.
Okay.
Thank you.
Okay.